Okay, so part E. Suppose the prior is that theta is continuously distributed according to CDF with support 1 to 2. Fully specify a single PB of the game, including beliefs. So we can actually approach this question in a similar way as we did the earlier questions, um, despite its sort of rather parsimonious nature. Okay, so let's go. Let's try and identify a pooling PB, and in general, in these sort of conceptual, under specified questions, it's probably easiest to look for a pooling PBE, as from what we have seen earlier, a pooling PBE will generally entail less incentive constraints than will a separating PBE. So we know that in a pooling PBE, all types will get the same level of education E star. Okay. The we can actually skip 2, right? Because we know that if all types are getting education level E star, the same level of education, then the level of education is not going to reveal anything as to the type of the worker. So the wage, which is the expectation of theta given E star, is just equal to the unconditional expectation of theta. Okay. 4, we're going to check for some in incentive compatibility constraints. So in equilibrium, what are the types getting? What is the worker getting? Well, what are the workers getting? Well, they're getting okay. Okay. Now, what if they deviate? Well, again, we want to make this off-path wage as harsh, as low as possible. So we want to and now in order to simplify this process, let's just say that because again we asked to specify belief. So let's make this as simple as possible and say that at all levels of education, okay, so even off path levels of education, beliefs are equal to the prior. What we mean by this, is that the prior distribution over types determines the firm's belief at all levels of education, and so we don't have any weird artificially constructed beliefs of path as we did in the earlier part of this question. So so this is basically going to be expectation of theta, because again the firm has the workers education level does not have the firm does not contain any information about the worker's type. So just to clarify, so the worker's education level does not contain any information about its type, and so given E prime, again your conditional expectation is just reduced to the unconditional expectation. Okay. So then if a type theta deviates, what does he get? He gets this, right? But then what is the optimal deviation, right? How do you what E prime maximizes this term, this expression? E prime equals to 0, of course, is the optimal deviation, which means that in equilibrium we need okay Now, again, and the right side is explained by the fact that if you deviate, your utility is going to be expectation of theta, because you're going to deviate, of course, to the most profitable education level, off path education level, which is 0. So this is most demanding. This condition is most demanding for when theta is equal to 1. So we will solve it in that case. Okay, and we get that. So we get that theta is equal to 0. Okay, so we then have a pooling PBE, which we can characterize quite easily, because again we've beliefs in this case are always set equal to the priors, and we haven't actually constructed any artificial beliefs. So we have right. So we have now. Notice that there's a distinction between saying that beliefs are not pinned down by the priors, right? So in this case, the off-path beliefs, yes, they're not pinned down, but that doesn't mean we can't set them to the priors, right? Okay. So P star. Sorry. So we have E star is equal to 0. We have and then we can just write beliefs equal to okay, we just write beliefs equal to prior distribution over types at all for all at all levels of education. Okay, so that is, now I should say that this is not a set of PB, this is one possible PB. Okay, so this fully characterizes a single PB of this game. Okay, now part F. So the key to solving this, well, first let's write down the worker's problem, right? What does the worker solve? Okay, so the worker is solving this problem. We can take a first order condition. Okay. So now we note that any separating equilibrium, the wage you get is equal to your productivity, because your type is fully revealed by your education level. We can differentiate this with respect to theta. Okay. Okay, so substituting then this into this, we get here we are very close to an answer, because Um, so there's another additional thing to note, remember here, which is again the education level of a type 1 worker, of a low type worker in a separating PBE is going to be 0. Okay, this is the result um, found earlier. So if we want education, we want to find education as a function of the of theta, that is to say worker strategy. Now, we can actually get this expression by calculating an integral of this form. Right. Okay. And of course, here we found that okay, we solve this and we get that okay. Of course, this is 0, so we have that the worker strategy is this, right? Okay. So that's the first part of the question. Second part of the question asks us to find the wage as a function of the education. So we note again that okay, so we can substitute that in. And we ultimately get that okay, so that is that. Now the key sort of thing in this sort of question is remembering the definition of a separating PBE, which stipulates that this is the case. And then we also need to remember that in a separating, this is the case. And if we keep in mind these two properties of any separating PBE, then some trial and error will eventually get us to the solution.